Okay, so here's this one. What is the particular solution to this differential equation? Oh, and I keep forgetting to fix this. This is actually K18 and K19. Okay, I have to fix those. All right, so what is the particular solution to this differential equation with the initial condition y of 3 equals -4? When you see this problem, you've got to cross multiply. So you end up with 3y dy equals x squared minus 2 dx. This is called separation of variables. So you have to make sure that there's only y's on the left as far as variables go and only x's on the right. Right now, before I go even further, let me just say what this means. This means x is 3, y is -4. That's the initial condition. All right, once you have the x's and y's separated, you take the integral of both sides, which is the antiderivative. 3 halves y squared equals a third x to the third minus 2x plus c. Now, the reason you use the initial condition is to find c. So I'm plugging in -4 for y, and then 3 for x. Okay. And this is practice exam 3. I just want to look at my answer key to make sure I'm doing it right. Okay, yes. So when you do the math here, you end up with this being 24, and then we've got 9 plus 8, which is 17. Wait. Oh, shoot, I messed up in my answer key. Because that should have been 3, and that should have been 3. Oh my gosh. I'll have to fix that too. So this is 9 minus 6 plus c. So this is c plus 3 equals 24. C equals 21. Okay. Now I'm going to take this and plug it back into here. 3 halves y squared. 21. Okay. Then you need to divide everything by 3 halves, which is the same as multiplying everything by 2/3. So we end up with y squared equals this. Plus, all right, multiplying by 2/3, so that's 14, I believe. Okay, now you have to solve for y. So I'm taking the square root of both sides, so I go plus or minus, and then this. Okay, and then you have to decide whether it's the plus or the minus one. So since y of 3 is -4, when we plug something in here, when we plug 3 in for x, we need to have a negative output for the y. So that means it's going to be the -1. Negative radical 14. Yeah, actually on the answer key I messed that up, so I'll have to fix it. Okay, now here's the last one. What is the particular solution to the differential equation, this, with initial condition here? All right, so this initial condition tells us x is e to the second, y is -1. So first you cross multiply. When we do that, we get x dy equals y dx. Are these all y's? No. Are these all x's? No. So you're also going to have to divide both sides by x and also divide both sides by y in order to separate the variables. Okay. Now these are all y's, these are all x's, so I can now do the integral of both sides. This ends up being natural log absolute value of y, natural log absolute value of x plus c. Then you've got to plug in the initial condition so that you can find c. So this is natural log of the absolute value of -1, natural log absolute value of e squared plus c. Now the absolute value of -1 is +1, so this is natural log of 1. And then guys, e to the second, that's already positive, so I don't really need the absolute values around the e to the second because it's a positive number anyway. And then guys, remember the way that logs work is that you can take this 2 as an exponent and put it out front like that. Natural log of 1 is 0, and then natural log of e is 1. So this ends up being 0 equals 2 plus c. So we have c is -2. So we've got natural log absolute value of y minus 2. Now you've got to get this natural log to cancel. So you'll put a base of e on both sides. So those cancel. Natural log of y. Okay. Now we need to drop the absolute value bars. So we can do that if we do plus or minus. Now you have to figure out if it's the positive or the negative. So since y of e squared equals -1, this is telling us that when we put something in for x, e squared for example, what comes out needs to be a negative. So it's the -1. So y equals -e. Okay guys, there it is.